Assalamualaikum and hi everyone. Jadi sesi kali ini kita akan lihat presentation para pelajar yang akan berkongsi ilmu bersama kawan-kawan bagi persediaan menghadapi final exam yang bakal tiba dalam sesi Dari Kita Untuk Kita. Jom kita tengok.
Assalamualaikum and hi. Today, I want to discuss about 40.1 First Law of Thermodynamics. First law of thermodynamics is the heat supplied to a system is equal to the increase in the internal energy of the system plus the work done by the system on its surrounding. The equation of first law of thermodynamics is Q equal to delta U plus W. Signs convention for Q, delta U and W. Heat positive, heat added or supplied or flow into the system. Heat negative, heat removed or released or flow out from the system. Change in internal energy, delta U positive, temperature increase, delta U equal to 0, temperature constant, and delta U negative, temperature decrease. Internal energy, U equal to F over 2 nRT. Energy, delta U equal to F over 2 nR delta T equal to F over 2 nR T final minus T initial. Internal energy depends only on temperature, T constant, also same T initial equal to T final, and also same delta U equal to 0. Delta U does not depend on P or V. Work done positive, work done by the system, and gas expansion, volume increase. Work done negative, work done on the system, gas compression, volume decrease.
Assalamualaikum and hi everyone. My name is Ainur Sheha Alia. Today I'm going to present about thermodynamics, isothermal, Isothermal is thermodynamic process that occurs at constant temperature. When temperature is constant, there is no change in internal energy, which is delta U equal to 0. First law of thermodynamics, the equation is Q equals to delta U plus W, which is Q equals to W. Related gas law is Boyle's law. It has two isothermal, which is isothermal expansion and isothermal compression. This is the graph of isothermal expansion and isothermal compression. T2 will be bigger than T1. The curve of isothermal graph must follow the same temperature curve, which is temperature is constant. When the volume is increased, the graph will be isothermal expansion, and when the volume is decreased, it will be isothermal compression. Isochoric. Isochoric is thermodynamic process that occurs at constant volume. When there is no change in volume, which is no expansion or compression, there is no work done on the system, which is W equals to 0 joule. First law of thermodynamics, the equation is Q equals to delta U plus W, which is Q equals to delta U. Related gas law of isochoric is Gay-Lussac's law or pressure law. There is two graph of isochoric, which is isochoric pressure increase. Second is isochoric pressure decrease. This is example of graph isochoric pressure increase and isochoric pressure decrease. T2 is bigger than T1. It is vertical line graph. When the arrow upward, pressure will increase, and when the arrow is downward, pressure is decreased. This is example of question. The expand isothermally from volume V1 to V2, a mechanical work of amount 1500 joule is done. Sketch the PV graph to show the process. This is the PV graph, which is pressure against volume graph. Second, determine the heat gained by the gas. For isothermal expansion, temperature is constant. Delta T equals to 0, and it will be delta U directly proportional to T and will equal to 0. From the first law of thermodynamics, the equation is delta Q equals to delta U plus W. It will give the answer of 1500 joule. Thank you.
Assalamualaikum and hi everyone. My name is Muhammad Farid bin Muhammad Jamaluddin. Today I'll be presenting the subtopic 14.2, which is Thermodynamics Processes. Thermodynamics processes. The learning outcomes are: the first one, to define the following thermodynamics processes: isothermal, isochoric, isobaric, and adiabatic. The second one is to discuss PV graph for all the thermodynamics processes. Thermodynamic processes is divided into four. The first one, isothermal, isochoric or isovolumetric, isobaric, and adiabatic. I'll be focusing on isobaric and adiabatic. Isobaric process. What is meant by isobaric process? A process that occurs at constant pressure, where delta P is equal to 0. From the first law of thermodynamics, we know that Q is equal to delta U plus W, where W is equal to P delta V. So Q is equal to delta U plus P delta V. Work done during the isobaric process with change of volume from V initial to V final is given by W is equal to P delta V, or P V final minus V initial, and then we get W is equal to area under PV graph. Note, all the heat added to the gas goes completely into increasing the gas internal energy U, and therefore its temperature increases. Isobaric process obeys Charles' law, on which V initial over T initial is equal to V final over T final. Okay, so we have two graphs here. The first one is isobaric expansion. Okay, notes here, the temperature, this one, this line, T2 is larger than T1. The horizontal line, arrow to the right, indicates that the pressure is constant. So we can see that when the pressure is constant, the volume increases from initial to final. Okay, so with the equation, Q is equal to delta U plus P delta V. So from this graph, we know that all the heat absorbed by the gas is used to increase the internal energy of the gas and to do work. Okay, so next one, isobaric compression. For this one also, the temperature T2 is greater than T1. But this one, the horizontal line, the arrow to the left, the pressure is constant, but the arrow moved to the left because V final is less than V initial, so the volume decreases. So the equation negative Q is equal to negative delta U minus P delta V. Okay, from this graph, the work done on the gas is used to decrease the internal energy and loss to the surrounding. Okay, adiabatic process. It is mean that a process that occurs without heat transfer into or out of a system. Note, heat flow can be prevented by thermally insulating the material. Okay, from the first law of thermodynamics, Q is equal to delta U plus W, but in this case, Q is equal to 0 because there is no heat transfer into or out of the system. So we get the equation, when we rearrange the equation, we get delta U is equal to negative W. Okay, so here we have extra info for adiabatic process. This is an example of adiabatic process, which the vertical flow of air in the atmosphere, where air expands and cools as it rises. You can see that the air expands and cools as it rises, and contracts and gets warmer as it descends. You can see the arrow over here. Okay, for the graph, this one is adiabatic expansion. Okay, notes over here. For adiabatic expansion, V final is bigger than V initial, on which W is positive value. You can see over here, and delta U is also the negative value. Hence, the internal energy of the system decreases. From this graph, we know that the gas uses its internal energy to do the work. Okay, this one is adiabatic compression. Okay, notes over here. For adiabatic compression, V final is less than V initial, on which W, the sign for W is negative value, and delta U is positive value. Similarly, an adiabatic compression is a warming process. As we can see over here, from the line T1 and T2, the temperature increase. Okay, so here is the equation. Delta U is equal to negative W. So it means that the work done on the gas is used to increase the internal energy. Okay, here we have pressure volume diagram or graph for thermodynamics processes. Okay, from point A to B, this green line, it is isothermal process. Why? Because the temperature line is the same. You can see that T at temperature at point B is equal to temperature at point A. So the constant here is temperature. And second one, pass A to C. Okay, this is adiabatic process because temperature at point C is less than temperature at point A. It looks almost the same as isothermal process for the line in the graph. Note over here, adiabatic curve is steeper than isothermal curve because in adiabatic there is changes in internal energy, temperature change, while in isothermal the internal energy U remain unchanged, temperature is constant. Okay, so the next one, pass AD. Okay, this vertical line, purple line, is Isobaric process. Okay, T temperature at point D is less than temperature at point A. So in this one, the constant is the volume. Okay. Okay, the last one, pass A to E. We can clearly see that the pressure is constant, so it means that it is isobaric process. From this one, the temperature at point E is bigger than the temperature at point A, so it means that the volume increases. Okay, here are some example question. Okay, 0.5 mole ideal gas is filled in a 0.5 meter cube container at 30 degrees Celsius. The gas is isothermally compressed to a volume of 0.3 meter cube. Then the gas expands isobarically to its original volume. Okay, so it asks us to sketch a PV diagram of these two thermodynamic processes. So the first step we have to do is to extract the information given in the question. So we have here N is equal to 0.5 mole. The first volume is 0.5 meter cube, and then the first temperature is equal to 30 Celsius, and we change to Kelvin. We get 303.15 Kelvin, and then the second volume is equal to 0.3 meter cube. Okay, so to sketch a perfect graph, we need to have all the values to plot on the graph. Okay, so we can solve all of the unknown values over here. Okay, so for the first one, which is isothermal, okay, so for isothermal compression, we can apply the equation P1V1 is equal to nRT1. So we substitute the information we have here into this equation and get P1 times 0.5 equal to 0.5 times 8.31 times 303.15. Okay, and then we get the pressure, the first pressure equal to 2.52 times 10 to the power of 3 Pascal. Okay, then we can use this first pressure to find the second pressure by using Boyle's law. Okay, P1 V1 is equal to P2 V2. So we substitute the value we have, and then we have this 2.52 times 10 times 0.5 equal to pressure, the second pressure, times 0.3. And then for the second pressure, we have the value of 4.20 times 10 to the power of 3 Pascal. Okay, so we go to the second process, which is isobaric expansion. So for isobaric expansion, we know that we can use Charles' law. V2 over T2 is equal to V3 over T3. So we substitute the value we have, and then we get 0.3 over 303.15 is equal to 0.53 over the third temperature. So we have the third temperature is equal to 505.25 Kelvin. But take note, this third temperature actually is the second one, because for the first temperature and the second temperature, it is isothermal, means that the temperature does not change, it is constant. So the temperature of T1 and T2 is equal to the same. So when we have all the information, we can plot the diagram. Okay, so therefore the PV diagram is looking like this. We have the y-axis pressure, and then the x-axis is volume. Okay, so note, okay, the process starts from point A to point B and then to point C, where point A to B is isothermal process. We can see over here, as I mentioned earlier, temperature does not change, so it lies on the same temperature line. And then point B to C is isobaric process, which by isobaric it means that the pressure is constant. Okay, so next question. One mole of helium gas expanding under adiabatic condition does 480 joule of work. Calculate the change of temperature of the gas. Okay, so first of all, we need to extract the information. So information given, we get N is equal to 1, number of mole, and then helium, which is a monoatomic gas, so F is equal to 3, and then the work is 480 joule. And then it also mentioned that it expands under adiabatic condition. So adiabatic process, we know that Q is equal to 0. So by using first law of thermodynamics, we know that Q is equal to delta U plus W. So in this one, expansion of adiabatic, so negative delta U is equal to W. So we substitute the formula for delta U, and we get negative F over 2 NR delta T is equal to 480. Then we sub the value we have over here into the equation, and then we get negative 3 over 2 times 1 times 8.31 times delta T is equal to 480. Okay, and then we calculate for the value of delta T, we get negative 38.5 Kelvin or negative 38.5 Celsius. Take note that from the question, it is not stated that the unit of temperature is Kelvin or Celsius, so both answers are accepted. Okay, notes over here. Okay, a negative sign, okay, for the answer shows that the temperature is decreasing with time. Okay, thank you for watching. That's all from me. Bye bye.
So hi guys, I am Rijayu from S15P6. So today we are going to do some revision on this chapter. Chapter 14.3 Thermodynamics work. So before I start this part, we're going to do some recap first. So some short recap. So first we need to remember this formula. So in this subtopic, we are going to talk more about this, and these two I won't touch it because my friend will explain it. So first of all, work when positive work means work done by the system. So negative means work done on the system. So when the system do work, it will expand. So when the work done on the system, the work will compress the system. So another formula to remember is this. Change in internal energy U is equals to FO2 and RT. And the ideal gas equation would be PV equals to nRT. So this thing we need to always keep in our mind. So there are 4 processes in thermodynamics. So work we will talk more on 3 processes, which is this. First one will be isothermal. Isothermal. So remember, isothermal, iso equal or constant. Thermal, remember thermometer, temperature. Constant temperature. So this means isothermal process is the temperature before the process and after the process would be the same. So second would be isovolumetric, or another name for it is isocoring. For this, I will prefer using isovolumetric because you can clearly see iso and you can clearly see this volume. So volume constant, temperature constant. So the last one is the last one is the third one, but thermodynamic work we only talk about 3, so I will take the last one. Is isobaric. So isobaric, iso we can clearly see equal, but baric, there's no shortcut way for it to remember, so just remember T we already use. Then the isovolumetric we already use the volume. So left the last one, P, pressure constant. We are going to start 14.3. Now it's a real one. Just now it's just short recap. So 14.3, we are talking about the work, and we are talking about the work. So how to find the work? Work is just basically the area under PV graph. PV graph is pressure over volume. So this is from this formula. V initial over V final, P dV. So looks simple, but we need to remember that work is dV. So the work done, the area under the PV graph means the area in between the curve and the V axis. So I'll show you. So first of all, isothermal. The graph is drawn like this. V, P. So this is the curve. So remember to put the arrow. If the arrow is from smaller volume to bigger volume, it's expansion like this. This is expansion. If you go another way, this way is from bigger volume to smaller volume is compression. So I will use the expansion as example. So here the P is high, the B is larger. So I will say P final. Initial P. So here is the volume initial, volume final. So to find the work, there's two formulas for this isothermal. nRT ln, in first one we use the volume. So V final over V initial. So if you lazy to remember, just nRT ln higher volume over lower volume. Another one would be pressure. We're using pressure. So it's the same thing as this part, same thing. Just P pressure final over pressure initial. Higher pressure over the smaller pressure, remember this. Also the work from the graph is just this part. Okay, V. Curve and the axis V. Now we're talking about the second one is isovolumetry or isochoric. So everything just start by drawing the PV graph. Isochoric, remember since it's constant volume, so this is just a straight line. Just one V only. And P final, P initial. So to find the isochoric the work, so look at this. This is just a straight line. There's no area down it, underneath it. Work is just 0. Because remember from this V initial over V final, then P dV. So since it's the same, remember in maths, we integrate the same V, we will get 0. In this case, it's the same V, so 0. So the last one, isobaric constant pressure. So same thing, we must draw this curve, this graph, not this curve, to see what happened. So constant pressure means the pressure is the same. Volume initial, volume final. So this is the work done. So to find, there's one equation for it. Pressure, same pressure, right? So just times with different volume. The different in volume. So just V final minus V initial. That's it. It's just simple as that. So don't forget to put the arrow. Expansion. So it's this. So go up. So I found one example of question for this part. So the question states that 2 moles of ideal gas do 2,500 joule of work to its surrounding as it expands isothermally to a final pressure of 3 times 10 power 4 Pascal and volume 0.02 cubic meter. So find the initial volume of the gas. So this is the information given in the question, and remember, doing this question we always need to change to SI unit, not SI unit first. So this question was very kind to us, already given all the information in SI unit, so we don't need to change anything. So for this kind of question, this is the information here, and isothermal, remember the equation for isothermal, later we will use it. So this question, how to solve it? So first of all, we need to start with this ideal gas equation. We need to find the final temperature first, because the formula for the isothermal is work equal to nRT ln V final over ln V initial. So we got N, we got R, we got final. We don't have the initial volume, and we don't have the T. So we use this to find the temperature. So we can just use pressure final, volume final equals to nRT T. So this is isothermal, so the temperature is the same, so no need to write T final, T initial is the same thing. So we rearrange it, we will get this. So we will just put the value inside. The pressure given is this. So 3 times 10 power 4. Volume final is this. 0.02. Yeah, no space. And the number of mole is 2. And the R is constant, just 8.31. We will get the temperature is 36.1 Kelvin. 36.1 Kelvin. So I better take another paper. So isothermal, we will use the equation for it. Equals to work equals to nRT ln V final over V initial. And we have found the temperature is this and work all this here. So we just put in the value. The work is 2500. 2 more, 8.31 the constant. Temperature is 36.1. And ln V final, this is given in the question. So V initial initial volume equals to 3.1 times 10 power negative 4 meter cube. So that's it. Thank you.